Hello and welcome to grade 10 math. We are starting a new unit again, and we're in unit 3, chapter 6, lesson 2. We're modeling quadratic equations. And so today we're going to look at creating scatter plots and then determining a curve of best fit. You may be used to lines of best fit for straight lines, but this will be a curve. And then determining what type of relationship is happening there. Secondary to this lesson is really to learn how to use a graphing calculator. Certainly there's many handheld ones that you can buy, but they are expensive, and in this day and age you can get ones downloaded on your device or access them through websites, and the best one that we're going to use is Desmos.com. You can get this through your student portal. You can download the app so you can have it handy on your phone while you're working on your computer. So I would highly recommend you downloading Desmos. Okay, moving along. We talked about yesterday the difference between linear and nonlinear. And so a graph of a linear relationship would be called a linear function. And a graph of a quadratic relationship would be called a parabola. Parabola, yeah. So draw a graph of a quadratic relation. Well, first of all, let's just recap what right. So if we had a linear equation, we would have a straight line, right? Straight and constant. And we talked about a few different. You could see a parabola like this going downwards. You could have a parabola going upwards, right? So this is a quadratic. All right, curved. Okay, changing. Right. All right, so good. Difference between linear and quadratic. So here we have a model of some from a textbook we have, and it's kind of like the human bite there. We can kind of already see this pattern. Kind of looks like those U-shaped measurements. So what we're going to do here is record the equation of the curve of best fit, but we can't just do that. This is not easy to come up with an equation. We need the help of a graphing calculator. So we're definitely going to use that, and I'll show you how we're going to do that. So this is a lesson about what quadratics mean and what parabolas look like, but it's more of how to use your graphing calculator to help you. Okay, so at this point, what we might want to do is it says, all right, use the middle of the teeth as your point. All right, so at zero, what point are we hitting? At 0, we're not hitting any teeth, so we can put 0 in there. At 5, extend until we hit the middle of a tooth. Okay, right there. We're at 15. At 10, where are we hitting closest to the middle of a tooth? Right there, 30. Okay, at 15, where are we going to hit a middle of a tooth? We don't really hit a middle of a tooth. Maybe this one. We're kind of missing. We'll say 40. At 25, 20. Okay, I think we're going to have to adjust this. So let's Let's back this up a little bit. So we said 30. Let's say 15. It's not. Let's say 35 then. And the next one, 20, is at 40. And then at 25, we're roughly at, I don't know, I kind of think that's below 45. And so if we'll say something like 43, at 30, we're right here, and it's 45. Okay, this is where it becomes interesting. So the pattern is going to repeat itself the other direction. So something like 43 again. And then at 40, we're hitting 40, 40, 40. But look, it goes 40, 43, 45, 43, 40. We're kind of repeating the pattern. At 45, we're hitting this one again. At 35, at 50, we're hitting right around here. At 30 again, and we're repeating those numbers. So at 55, we're hitting at, well, it's kind of different here because, oh, I guess we're hitting at 15. And at 60, well, there's no tooth at 60, so. All right. So at this time, we want to bring that over to our Desmos. So as I adjust the screen a little bit, I want you to go to desmos.com or pause the video, download it on your device, or open it up on another window tab and see if you can get both side by side, or at least you can flip back and forth. Okay, so pause that, and then we'll get this ready. All right. So we can clearly see all the information we need. I'll go back to that slightly bigger view. Okay, so what we're going to do is, it's easy. We've used Desmos in the past, most of you, and you've done linear functions, such as this, right? And you could zoom out, you could zoom in, okay? And so that's fine, and linear functions are good, and it works really well for that. But quadratics are a little different. So quadratics would be in a different form. Remember, just looking over here on the right again, that quadratics will have the form of y equals a as some sort of number, x squared plus b as some number times x, and then plus c. So we're looking for this pattern of what is a, what is b, and what is c. And we cannot figure this out yet in the course to know how to figure those out without the help of the graphing calculator. So we pretty much have to use a graphing calculator to get an accurate number. Okay, so the thing that you're going to have to do is you need to take this table and get it into a graph. So here's what you do. We press this plus sign, we go down the table, and now we have an x and a y, just like we have over here, an x and a y. All right, so we're going to just plug those numbers in. At 0, 0, okay, the next one is 5, 15. Okay, we keep going. 10, 30. Now, I want to pause just for a second. Before I go too far along, I want to show you, it's, well, okay, no, I'll show, we'll keep going. 15, and there's just more than one way to do this type of thing. 40, 25, and 43, and 30, and 45. And we're just plugging these numbers in, 35 and 43. Now the numbers start to repeat themselves, 40 and 40. And you might be saying, well, what's happening with this graph? Let's zoom out a bit, and you start to see this pattern happening, which is great. Okay, 35 and 50 and 30, 55, and we pretty much repeated the numbers. 0 and 0. I don't think that matters that that happened. Okay, so here we go. Oh, it didn't like that. Didn't like that one. So let's put 0. Still didn't like it. I don't know why that's not there. Oh no, it's 60. 60 and 0. Right. There you go. Beautiful. Okay. This is what we want to do then. It's really important that they call this x1 and y1. That's going to make what we do in the next line really important. We're going to do what's called a regression. So let's write that somewhere. We need to do a regression. And so need a regression. So you're going to do y1 and this sign. Instead of an equal sign, you're going to say it's something like, it's approximately this, ax to the 1 squared plus bx1 plus c. We're going to type that in, okay? Watch this. So in line 2, it's going to compare to this. But in order to make it note it has to compare, you're going to call it y1, which is the same as y1 up there. And instead of an equal sign, okay, you got to find this by doing this keyboard. You have to find this symbol. It's the approximate symbol. And we also know now we need the letters A and X, but I need to put this one first. I mean, what I'm showing you right now, I want you to keep in mind this video, because from this point on, you'll be able to follow this video over and over again to make sure you follow this. Now, we need ax to the little 1, and then we need to square it. But the square has to come after the 1. Okay, look, we already see a graph coming in here. Now, it's not the right one, but it's starting to interpret it. Now, plus b, so back to our keyboard, b and x, and remember, it still has to be x to the 1. You have to do that. And already, look, it likes it. It likes it very much. It's really close to what we have there. A little different, but now plus c. So back to our keyboard, c. We don't need a 1 on that one. Everything's fine. Okay? And now what it's done is made it even closer to the values. All right, so very interesting. Now, what I want you to do is, I don't really like how it's all crammed in here. So what we're going to do is I'm going to show you the tool. Use the toolbox here, the wrench, go in there. And so there's some things you can do, like watch here. I could remove grid lines if I didn't want that. I actually want my grid lines. You can have arrows for your coordinates or not, doesn't matter, it's up to you. You can have your access numbers disappear or your access numbers reappear. You can take away the minor grids if you kind of like to clear it up a little bit. I think minor grids are helpful in this case. Okay, now on your x-axis, you want to label this. So what did we call it? Look over here on the right again. We called it width. Okay, so width. Okay, we won't put the millimeters in, but you can put millimeters in there, right? And our y-axis we called depth. All right. Here's the other thing. We want to be able to have a good image of what's happening here. So we want our lower form to here be negative. I always don't make it 0. Give yourself some wiggle room. -5 so you can see it. If you make it 0, then this line will be right on the edge and you won't see much. And then what's the highest x value we go? We go to 60. So let's just build an extra 5 in there. So go to 65. You're going to see how this is going to make your graph look a lot nicer. So on this side, again, for y, let's go start again -5 because you want a little bit of a spot there. And the highest we end up going on y is, well, 45. So let's go up to 50. You're going to see what that does. So, like I said, you have a little space here. You have a little space here. It's putting depth there, so I'll show you what you can do there. Just give yourself even more space. So -7. And I put depth on the other side now. Okay, so you have depth, you have width, and you have a nice parabola that's showing. Okay, so that looks good. What we can do at this point is you can look at so what it's done is it's interpreted your line, interpreted your data, made a line, a best fit, a curve, a best fit, and it's given you the A. So look over here on the left. It's giving you the A, B, and the C. So we sort of go over here and we say, well, we found out the information we needed. We needed to know that A was going to be -0.05. Let's just round it to 2 decimals and see what happens. Now, if you round too early, it is really going to mess up your graph. So 2.9 we'll say for B, and for C it looks like 1.6. Maybe you want to do 1.64 maybe. Yeah, let's go 2 decimal places we said. So 293. Okay, so let's say we were to make that into an equation. And we said, okay, well, my equation then is y equals, what was A? -0.05 x squared. We're just putting these numbers in for here. Plus 2.93 x and plus 1.64. So that's our new equation. Just to see what that looks like, let's go and back to the left side, the Desmos, and punch in what we think the equation should be. Y equals -0.05 x squared. We don't need to put the ones on it this time because we're not saying it's the same line. It's going to overlap that line, but it's not the same line. Well, it's going to be very close, we hope, to that line. 93, so 2.93x. Really make sure that it's exactly the way it's written. And so there we go. Now, well, what happened? Our blue line is a little off because we rounded things too much. So, anyways, I mean, it's still pretty good. But no, that's one reason why you don't want to round too early. So if we put these exact numbers in above, A, B, and C, to here, we'd have an exact curve. So let's actually, I'm going to erase that. So what else can we do with this? We have our width, we have depth. Let's say, okay, we'll just finish this question over here on the side. And what were they asking? So they asked, what else were they asking? What type of relationship is this? Well, we'll say it's a quadratic relationship. Quadratic relation. Okay, well, what was that? So I do want to show you some other things that you can do. So again, we turn this graph, this table, into an equation, or into a graph, and we got an equation out of it. All right, so our A, B, and C, and we wrote it over here. So the other thing I wanted to show you, which is pretty cool, because if you're doing an assignment or even a quiz and you want to import your graph, you can share a link to it, you can print it, then crop it, or I would say maybe export it. Okay, so I've already did this before, so I'm going to import it over here. And so at this point, I'm going to just green here, and we're going to do insert an image. And I don't remember where I saved it, so that's the thing is remember where you save things if you do that. Desktop. Okay. The only thing it does is make it too big, but so we can bring that down here. And again, that's what you could do in your assignment. Even you could bring that and show that you did some proof there. I don't know what all these lines are. It's not really. I don't know where those showed up on, but I don't see those here. Not sure why I did that. Anyways, either way, it looks pretty good. There's our graph. Okay, so that's again one way we can use Desmos. Maybe a lot of work putting in all that information, but when it gives you such an accurate graph, it's really great. Okay, some things to note here is this number where it says it peaks doesn't really match what our graph did, but sometimes that happens. Okay. All right. Next question. Well, this time they gave us the table with the numbers already in it, which is nice and handy. So, all right, great. So here we go. We use this, it's telling us to use a graphing calculator. Jimmy is training for a school baseball team. The table shows the heights and the horizontal distances of the baseball after Jimmy hits it. Okay, so at 0 horizontal distance, so where Jimmy is standing is 0. And where the ball is going to go, here's the distances. And at the same time, you hit a baseball, it's going to go up in the air. So look at these values are increasing. So what do they want us to do? Create a scatter plot and have data on your graphing calculator and show your teacher. Okay, determine the equation of the curve. So we're going to define again our A, our B, and our C, and then we can describe the relationship. So let's minimize again, and we go over to our graphing calculator. We're going to have to clear this off. And so sometimes I like to get things set up ahead of time. So our wording is not width anymore. Look over here on our X and our Y. So our X is now the horizontal distance. In meters, you can even put brackets in there. I'd like you to follow as I go along. Okay, so pause it as much times as you need in order to keep up. So went to the wrench, put that in. Our y-axis is something else. It's going to be the height, and we're going to have meters again. So we know that we can even look at these numbers, and we can say, I want, I think at negative, 6 worked well last time. And what's the highest value we're going on the x? Looks like 35. So let's give ourselves a little more room than that. Maybe 45, because it might go further than that. And then I like the grids. I like having the grid lines. And I don't know what that would be weird, eh? So you put that. Our XY, again, -5 about. And what's the highest on our height? 18. So let's go with 20. Okay, sorry you can't see what I've been writing here. 20 in here. Oh, okay, so that's good. There's our grid. There are a couple neat things that you can do. You can actually reverse the contrast, make it a dark thing like that. Kind of neat. But I think I like the white background. It's easier to see things. Okay, so let's, again, what did we do last time? We started off with this plus symbol. We grabbed a table. Again, x1, y1. So 0, 0. I'm going to pause here and let you catch up, okay? Now, so catch up and follow along exactly what I do. Next, we're going to, before we put all this information in, I'm going to go and build that model. So remember, it was y. Remember over here, it was y is similar to y1, similar to ax1 squared plus bx1 plus c. You got to put these numbers in, okay? So 1. Okay, and then you have to find that symbol on the keyboard right there, not 2. 2 of them. Okay, then we're going to go a x, and we need the numbers again. 1. You got to do the 1 before you do the squared. So do the 1 before you do the squared. Plus bx, again 1, and plus c. Okay. So right now it's telling us our a, b, and a c are 0, 0, 0 because that's all the information we have. So let's go above here, back to this box. And now we just do our numbers now. So 5 and 4.5. 10 and 9.5. 15 and 13.5. 20 and 16.5. Again, pause the video if you want to do this ahead of me and try to analyze it without me, and then you can do the video afterwards to see if you were on the right track. 35 and 13.5. Okay. Now, if you notice, we're kind of running out of room here, so we can adjust our wrench again to say, let's give ourselves some more space here. I think I was at 45, so what if we went to 55 or something like that? Okay, and then have a look. Oh yeah, so 55 gets us to the end. That's good. So even though it says our total was 18 and a half, the line's not showing that. So it says if it would normally follow this pattern, it would never reach that high in a normal way. So anyways, what it's done is given us our A, our B, and our C. And notice, like, we didn't have all the points, right? The points ended here. So the regression, we called it a regression, charts this as if it's going to continue on that path. And where is it going to hit? Okay, so create a scatter plot, show it to your teacher, you did that. Determine an equation. Okay, well, A is equal to, maybe we'll carry a few more decimal places because the last one we rounded too early. 282. B, and you got to make it it has to be negative. If you notice, all negative ones end up opening downwards. B is 1.4427. And C is also negative 1.063. Okay, so then we know our equation. Our equation is y equals negative 0.0, well, we'll round, 3x squared plus 1.4x plus, no, can't be plus, it's negative, 0.06. Okay, so there you go. Now, how would you describe this? Well, it's nonlinear. It is quadratic. It rises, then falls. So that's it. Yeah, that's great. And the things you can tell, there's some interesting things you can tell. Actually, some strange things that don't make sense. But if you go back to your Desmos graph and you hover right over a point, it'll tell you what that point is. And so it's saying it's going to hit the ground, right? If our height is 0, then our ground is 49.8. So the ball will leave and then hit at 49.8 meters away from where you hit it. So you hit it 49 meters. I'll tell you the strange thing. If C is the y-intercept, he's actually hitting the ball underground, which doesn't make any sense. Usually when we hit a baseball, if we hit a baseball, it's usually above ground. Okay, let's say we want to save this graph, and then we want to import it. So I can save it, export the image. Look what we can do here. We can make it the small, we can make it medium, make it large. We can do, like medium, we can do thickness of the lines, make it stand out more. Okay, download. Save it there. Okay, go over to your document. I wonder if I can drag it. I don't know. No, it doesn't let me do that. Alright, insert picture, Desmos 2. It's going to make it really huge. And so, find the corner, zoom in, and there we go. So what I was saying before was, sometimes things don't always work out perfectly here. If we were, usually, if a person's hitting here with a bat in his hand, he's usually like a meter, hitting the ball at a meter, not underground. If 0 is ground, then they're saying he made contact with the ground underground, but that doesn't make sense. So sometimes things are a little bit off. But anyways, the whole table doesn't make sense because you're not going to hit a baseball at 0 height on the ground. You'd probably hit it off like 1 meter or something. But anyways, they're not always perfect examples. The better thing is we learned how to take a table of values and do a regression in Desmos, which is a very good skill to learn. All right, so practice that and get good at it, and use Desmos to help your work. Okay, thanks for watching.